Hey you guys, this is just a quick lesson on complex numbers or imaginary numbers. We're looking at the negative square roots or the square roots of negatives, however we want to say it. So thanks for watching. Don't forget to like, comment, and subscribe. Imaginary numbers. Yeah, so, math people got to a point where they felt like they'd done as many calculations as they possibly could, and they weren't finished though. So, of course, they needed more to do. So after all the real numbers came all of the imaginary numbers. And some people like these a lot. Some people like them a lot. Okay, like, I don't know, quantum physicists, people. Right? E equals mc squared. As it turns out, and this is my understanding, it's not the whole formula. It's actually E equals mc squared plus q. We just don't include the plus q because it's an imaginary number. So I don't know. You guys didn't care about that. In any case, I, which stands for imaginary, right? I is the letter that we use for imaginary numbers. It's also why we don't use I in general for unknowns or solving equations, because I has a value. I is the square root of -1. Okay? So when we start simplifying these, we can separate -1 out of it, which also allows us to separate I out of the expression as well, which we will see. Okay. Now at the bottom of here, we see something kind of freaky. Always look for a factor of -1 for even roots to make it I. Yeah, that's good. Yeah, I apologize. The index, right? I mean, that one's 2 right there. I mean, if it were 4, it would still be even. That's the only time we really need imaginary numbers, because if I took the cube root of -1, it would just be actually -1. Okay, so when they're odd values, we don't really care about the negative. It's only when we have even roots. So let's just consider what we're looking at here at the bottom. I to the power of 1 is I. Right, we could tag on a power of 1 and it looks pretty. But I squared, well, if we look at the definition of I, that's I squared. That would be I multiplied by I. And I is the square root of -1. So we'd really have the square root of -1 times the square root of -1. Now, based on what we've done in the past, we would want to just combine this and say, I got the square root of -1 times -1, which would be the square root of 1, which is 1. But we can't do that, and that's why we say we can't just simply start multiplying the radicals like we're used to. Well, kind of the way we want to look at this is that we really have -1 to the power of 1/2, but we're going to square that. You guys don't care about this, but this is why it works, okay? And what would we do with the exponents? We'd multiply them, right? So it'd have -1 to the power of 2/2, which is -1 to the power of 1, which is just -1. Yes, I did include many steps there, and we don't need all of them. Some of you don't need all of them, and that's okay. If you do need all of them, that's okay as well. But I'm just trying to explain why it is the way it is. Now, that was I squared. Let's look at I cubed as well. All right, I cubed would be the same thing as I squared, which we know is -1, right? Multiplied by I. If you want to see that power of 1, it's 1. Right, so I just changed 3 and made it 2 plus 1 and broke that up. Well, I squared, we already know, I'll use a different color. I squared, we already know, is -1. And I is just I, so it's like -1i, which makes it -I. Let's look at I to the 4th. So I'm going to break this up into I to the power of 2 plus 2. I'll show all the steps on this one, which makes it I squared times I squared, just doing the exponent rules. And we already know I squared is -1. So we got -1 times -1, which is 1. and then we got this group. Now the nice thing is with those 4 powers, which is all we really need to know, it just cycles, okay, because every 4th power is just 1, so I to the 5th would be the same as I to the 4th times I, and I to the 4th is 1, I is I, 1 times I is I. And then again, it just goes in a cycle from there. All right, write this answer in terms of I, so we're just going to simplify it just like we would if there wasn't a negative in the square root, which means I'm going to break this up into -1 times 13. I just want to separate that negative from the rest of it. So I've got the square root of -1 times the square root of 13. And the square root of -1 we know is I. And the square root of 13 simplified is the square root of 13. Done. Square root of -49. So again, I'm going to break this up. The square root of -1 times 49, which breaks up into the square root of -1 times the square root of 49. 49 is a perfect square. So -1, the square root of -1 becomes I. Square root of 49 is 7. Just know that it's informal to write it as I times 7 or as I7. Kind of like I is the variable. We just need to switch these around and make it 7I. Done. So complex numbers are written in this form, a plus bi. A and b are, of course, real numbers. So a, for example, could be a negative number, -5. B could be some other value, 4. And if it were -4, we'd just make it -4i like that. Okay. But these are the forms that we're going to be using, especially when we start multiplying these as binomials, which we will do. Just in the final form, we want the I term to be the trailing term, and then whatever the constant is to be the leading term. So this is a complex number. We're going to write it as a complex number, and we'll show it in terms of I, but we'll show it in its formal term as well, formal notation. So the square root of -64 is the same as -1 times 64. Now I'm going to do this one at a time, all right? So we can break this up into smaller problems. So that's the square root of 1 times the square root of 64. And the square root of 1 is I. And the square root of 64, that's another perfect square, is 8. So I really have 8i. And then this is all subtracting whatever we get from the square root of -144. And that, again, we're going to break that up into -1 times 144. So that's the square root of -1 times the square root of 144, which is a perfect square. So we have I times square root of 144 is 12. So we're going to make that 12i. Now these are like terms because they both have i's with them. So I've got, in terms of I, when I combine these, how many i's do I have? 8 minus 12 is -4 i's. That's the answer the homework wants. Formally, though, if we were to write this as a formal complex number, we have nothing, and then we would subtract 4i. Now, don't worry about that right now because, again, the homework just wants -4i. But I didn't have any constants out of any of that, any of those operations that we did. But I just thought you guys might want to see that. Perform the indicated operations and simplify. Again, this is just combining like terms, no multiplication on these. So we still don't have to worry about that I squared business, but we will in a moment, and that's okay. Rewriting this, we've got -7 minus 2y plus, since it's just addition, it's really plus -17 plus 9i. And yeah, you can make that -17 if it helps you visualize that better. In any case, we're going to combine like terms. So I got -7 and -17, which when I combine them, I get -24. And then my i's, I got -2i's there, positive 9i's. So that would give me a positive 7i's. Done. If you guys had seen x's there instead of the i's, you would have done exactly the same thing. That's exactly what we're doing right here. Again, that's only if i's don't have any other powers, which again they will have once we start multiplying these.
So you just combine like.
All right, this time we're going to subtract. Now, again, I kind of like to look at this stacked. So negative 7 minus 2i. And then in the other parentheses, we've got negative 17 plus 9i. I think these are the same terms, but we're subtracting these values. Okay, so we're going to stack these up. Negative 7 minus negative 17 would be the same thing as plus 17 right there. So that's going to give us 10. And negative 2 minus 9i's would give us negative 11i's. Done. We could look at this differently, right? So if we had seen it like this with subtraction, we could just change the we will change the signs on the inside of that parentheses, and then we kind of get rid of it. Speeding through that a little bit, but you know, we've done plenty of that stuff before. So that's minus 9i right there. And then you know, it combined to be the same values on this. Perform the indicated operation and simplify. Just regular exponent rules on this one. If we look at the 5, it has a power of 1, and the I has a power of 1 as well. So we're squaring this, and yeah, you could use the exponent rules. We'll show it expanded. 5i times 5i. And we can rearrange this since it's all multiplication, so that it's 5 times 5 times I times I. 5 times 5 is 25. And then I times I is I squared. Now again, if we need a little help remembering, right? I is the same thing as negative 1. And we just squared that, right? So I squared is negative 1. Okay, and we've already seen those details. So I'm going to take that I squared and just make it a negative 1. So I've got 25 times negative 1, which is negative 25. I showed a lot of stuff on that, and I hope the explanation was detailed enough. But it's not necessary that you do all those steps. There it is, the I problem, right? So we know it goes in groups of 4. So really I'm looking at that power of 49. And every fourth term is just going to cycle back into a 1, right? So what that means I can do with that 49 is I can take it and I can divide it by 4, because every fourth term is 1. So that would give us 12, right, minus 4. We can show all the long division. Not that anyone wants to. Minus 8, and we got 1. That's our remainder. The remainder is important on this, because after dividing by 4, since every fourth term is 1, it really means that it's equivalent to I to the power of whatever the remainder is, in this case 1. And I to the power of 1 is I. Done. Let's look at this differently, all right? So if I took that I to the 49th and changed it to I to the 48th times I to the first power, because 48 is a multiple of 4. In fact, it's the one that's closest to 49, right? Well, I to the 48th, here, that would be 1. And I to the power of 1 is I, so it's still I. Hopefully that wasn't too confusing. Perform the indicated operation and simplify. We got multiplication on this. And this is 4i, which we are going to need to distribute into the parentheses. So 4i times negative 6 would be negative, what the heck, let's show all of it, okay? So that'd be 4i times 6, and then we're going to add We also distributed the 4i times the 9i. And we can, since it's all multiplication, we can rearrange this because of the commutative property of multiplication. So that's 4 times 6 times I.
Isn't that negative 6?
Dang it. Thank you. Negative 6. Which will be crucial. Right? And then we got the i's. I can change it to 4 times 9 times I times I. Yeah, you guys are seeing that I squared business. 4 times negative 6 is 24 times I. Plus 4 times 9 is 36. And I times I is I squared. Now we can't really do much more with that 24i. But we can do something with that I squared here. That will end up becoming a negative 1. Because I squared is negative 1. So I really got 36 times that negative 1. Which gives me 24i. And we'll just change that to minus 36. But again, this is not a formal complex number. To do that, we're going to need to change this to negative 36 and then minus the 24i. And that would be it. So we'll just multiply these. Nothing too bad on that. This is just multiplication of two binomials, which we have a lot of experience with now. So I'm going to distribute the 7 into that parentheses. We'll write that out. 7 times negative 1 minus 11i. And then we'll also distribute this negative 12 into that parentheses as well. So negative 12i times the same negative 1 minus 11i. Well, this allows us to distribute these. 7 times negative 1 is negative 7. 7 times negative 11i is negative 77i. And then we'll distribute the negative 12 into the parentheses as well. So plus 12i plus 132i squared. Well, from here, we should hopefully see that we got these two like terms, the i's. So I got negative 77 i's and positive 12 i's, which would give me negative 65 i's. And I do have that negative 7 leading in the front. But this negative 1 I, let me start that over. I squared is really negative 1, right? And that's multiplied by that 132. So that really becomes a negative 132 right there. Well, now I've got two other like terms that I can combine, the negative 7 and the negative 132, which is negative 139. And I've also got that negative 65i. Well, that's a formal complex number notation, so we're good. We do have a difference because when we're working with binomials, when we got x squared, it just kind of stayed x squared, right? But now that we have I squared, we're changing it into a negative 1. I don't know, that doesn't seem too bad. This one has the same idea. I mean, if you have the formula, that's good. But most of us can't remember that, and that's all right. So let's just expand this. 8 minus 12i times 8 minus 12i. And we're going to distribute the 8 into the parentheses. So that's 8 times 8 minus 12i. And also the negative 12i. And we'll multiply it also by that set of parentheses, 8 minus 12i. And then we'll distribute the 8, 64 minus 96i. And then the negative 12i as well. So negative 96i. And that's a positive 144. But it's I times I, so it's I squared. All right, we'll double up the steps on this one, right? Because I got this negative 96i and this negative 96i, which is negative 192 i's. And I'll just change that, the I squared, right? That's going to become negative 1. So all that does is it changes that positive 144 into a negative 144 there. Well, then I'll combine these two like terms. I got 64 and negative 144, which should combine to a negative 80. and then I got the negative 192i. And again, that is formal complex number notation. Evaluate this expression and write the result in the form a plus bi. This is kind of like rationalizing denominators. We don't want i's in denominators. Why? Because it feels weird. Okay? So we don't want it there, but we can get rid of it pretty easily. Now notice, in the past we would maybe be concerned a little bit about that 4, but right now we're not. All we're really concerned about is that I. So I got to get rid of it, right? How do I do that? I just make it a negative 1 by multiplying it by I. But this, again, has to be a factor of 1, so if I do it to the denominator, I also have to do it to the numerator as well. Okay? So if I were to look at this and distribute that I, I'd have negative 4i plus 3i squared. And we know where that's going, right? This is all divided by 4i squared. And the I squareds are going to be become negative 1. So let's go ahead and multiply those out. So this is our new expression, but it's not technically in formal complex number notation, right? In that numerator, we can switch that around. And if I remember right, in the homework, they want you guys to separate these, okay? So what I mean by that is, instead of making one gigantic fraction like we have right there, we're going to make it 2 smaller fractions. So this now becomes negative 3 over negative 4. We'll evaluate that in a moment. And then we're going to subtract that 4i also over negative 4. Now, yeah, some of you notice that that negative 4i and the negative 4, that's just going to change that into plus, whatever it is. And we do need that in there so that it's fully simplified. So simplifying these fractions, I now have 3/4. And then we're going to add this to 4 divided by 4 is 1. So I just really have I right there. You know, if you want to write the 1 there, that's okay too. But that's pretty good. It is possible that on the homework they would accept the decimal. So, but I'd like just to keep it as a fraction, just to minimize the amount of work it is. So this takes us back, I forget how far back though, but I think it was module 4 with the polynomial stuff. Conjugates, which was kind of how we rationalized, was it rationalizing? Yeah, we kind of used them to rationalize denominators in module 5. So 6, yeah, 6, whatever. In any case, we've seen this before, right? So if you saw a plus bi, its conjugate would be a minus bi. It's not that we're taking the opposite of either term, it's just we're changing the operation from addition to subtraction or subtraction to addition. Now this does lead to something pretty cool in a very nerdy way, which is why I like it. But we're going to show that to you in a moment, okay? Find the conjugate of the following expression, 2 plus 2y. The conjugate is, so we still have the same two terms, 2 and 2y, but instead of that being plus, we're going to make it minus. Done.
That's it?
All right, so this one's kind of different, right? Because we say we're going to change the operation. Well, we got to remember there's a 0 leading in the front there. It was a phantom 0, not imaginary, right? So we're going to keep the same two terms, 0 and 7i. This one was subtraction. I'll use a different color. This one was subtraction, so we're just going to change it to addition. Done. All right, this leads us to something, I don't know, kind of funky, right? So let's look at some terms here. You guys give me a number. Not too big, right? 2. And what else? 5. Okay, so if we looked at this term, well, this binomial, you want a plus or minus? Plus. All right, we'll do it with a different color. So if I looked at this and said, what is its conjugate? Then I would have the two same terms, 2 and 5i, but we'd have that as minus right there. Now, we know what happens when we multiply these with, I guess, not imaginary numbers, real numbers. And also the radicals, and it gets rid of the radical for us, which is pretty nice. But what does it do to the I stuff? Well, let's multiply this out, because this is a nice example for us to see what the heck is going to happen right here. Well, I would multiply the 2 times that parentheses, right? So 2 times 2 minus 5i. And then I'd multiply the 5i into the parentheses as well. And that's a positive 5i times the 2 minus 5i. And now we'll distribute these individually. Now, just having gone this far, some of you know exactly what's going to happen, which is, I don't know, it's pretty cool. The two 10i's, the negative 10i and positive 10i, those cancel out, which is what conjugates are supposed to do, right? So I ended up with 4 minus 25i squared. However, the I squared is going to become a negative 1, effectively changing that to a positive 25. Now here's the other nice thing about that is if we gave the 2's x's like this, right, this would be x squared down here. I did skip a few steps right there. But this shows us, right, we've seen the difference of squares. This is the sum of squares, right, because 4x squared is the same thing as 2x, but we squared it. And then 25 is the same thing as 5, but we squared it. And we added them instead of subtracted them, right? So we have an a and b value. And what do we have to start out with? 2x and 5, well, 5i, right? That's the only difference. This is the I stuff. After doing this enough times, math people celebrated because they found that not only can you do the difference of squares, but you can also find the sum of squares, as long as you have imaginary values. Yeah, that's right. So if you see a squared plus b squared, then it's going to give you the 2 conjugates, as long as you know what a and b are. But again, it's going to include that I value stuff. Find the product of negative 3 and negative 4i and its conjugate. Okay. Let's look at this. We got negative 3 and 4i, and the first one is subtraction. So the next one with negative 3 and 4i would be addition. That would be its conjugate. So we know what its conjugate is. All right, there's our conjugate, purple parentheses, whatever. But again, this is the nice thing about this is we can see the a value is negative 3, and the b value, is 4, not 4i on this. Now the reason why we like this is because we get to skip, if we know the rule, several steps, and we can do, well, it would be a squared plus b squared, right? And now we know what a is. A is negative 3, and b is 4. So negative 3 squared is 9, and 4 squared is 16. I'm just going to add these two together to get 25. There it is. That would be the product. Now, would you get the same thing if you multiply these out? Yes, you would. Okay. If by chance it asked us to write this as a complex number, you'd have 25, but then you would add 0i. If the homework wants it like that. On the test, I'm okay with just 25 though. Well, we can see from that example, and I guess the previous one as well, that we can get rid of the I values by just taking conjugates, right? So if we see some kind of rational expression with a binomial in the denominator that has an I value, we just need to multiply it by its conjugate, again as a factor of 1. So in the numerator and denominator, which will get rid of the I value. So again, just like we just said, rationalizing the denominator, we have negative 6 plus I, and its conjugate is negative 6 and I, but this time it's going to be subtraction. Now again, this needs to be a factor of 1, so we're going to multiply it in the numerator as well, and acknowledge that that binomial is there as well. Alright, so let's multiply these out then. So in the numerator, let's start with the numerator. Negative 5 times the negative 6 minus I, and 7I times the negative 6 minus I as well. And then all over, negative 6 will distribute into the parentheses and I as well. Alright, let's do the actual distribution now. So we'll distribute the 5 and the 7I. So there's the numerator, right? Just all we did was multiply and distribute. Next up, let's distribute this negative 6 and the I into those parentheses. And there's the denominator. And again, right, we got those two middle terms, positive 6I and negative 6I, which are going to cancel out. But not only that, but I squared is going to become a negative 1. So in the denominator, we've got 36 minus negative 1, which makes that 36 plus 1, which is 37. Oh, I forgot in the numerator, sorry, that's negative 7I squared, right? Well, let's combine the like terms in the numerator as well. So we got this 30, wow, there's nothing I can combine it with yet, 30. But I do have 5I and negative 42I, which is negative 37I. But that I squared is going to become a negative 1, which is just going to make that a plus 7 right there. Well then, let's combine the 30 and the 7 to give us 37. And we got negative 37I. And this is all over 37, so I'm going to split this up right now into two separate fractions. And we can see with the I having, I guess we could call it a coefficient of 37. This is just going to cancel out, and that's going to become 1 minus 1. 1 minus 1I, done. And yeah, I mean, you don't really need the 1 there if you don't want it either. Whatever.